How they built skyscrapers in 1900. At the beginning of the 20th century, cities started to grow upward. There were no tower cranes, no hydraulic lifts, no computer models, no modern safety systems. And yet, some of the first skyscrapers were built, tall, heavy, and permanent. So how did people in 1900 construct buildings that changed city skylines forever? The answer is not mystery. It is engineering, organization, and new materials. The problem of height. Before 1900, most buildings were limited to a few floors. Stone and brick walls had to be thick to support weight. The higher the building, the thicker the walls. At some point, walls became too heavy and too wide to be practical. Height was limited by physics. The steel frame revolution. Everything changed with steel. Instead of walls carrying the weight, a steel skeleton did the job. Columns and beams formed a rigid frame. The walls became light skins around it. This allowed buildings to grow upward without becoming massive at the base. The first true skyscrapers were born. How steel was made in 1900. Steel was produced in large furnaces using coal and iron ore. Factories rolled steel into beams, columns, plates. These parts were standardized. This meant builders could plan structures in advance and assemble them on site like a giant construction set. No cranes? No problem. Heavy steel pieces were lifted using steam-powered hoists, pulleys, winches, and temporary wooden towers. Everything was powered by steam engines and human labor. Loads were raised slowly, often just a few meters at a time. Safety depended on planning, not technology. Rivets, not welding. Welding was not common yet. Steel frames were connected with hot rivets. Workers heated rivets until they glowed red. They placed them into holes and hammered them flat. As the metal cooled, it shrank, pulling the joint tight. This created extremely strong connections. Many of these joints still exist today. Elevators made height useful. Tall buildings only make sense if people can move inside them. Electric elevators were introduced in the late 1800s. By 1900, they were reliable enough to serve tall office buildings. Without elevators, skyscrapers would have been useless. Fire was the biggest threat. Early skyscrapers faced one major danger: fire. Wood floors and open stairwells were deadly. Engineers responded with fireproof materials, enclosed staircases, steel protected with concrete. Cities also created new fire regulations. Safety became a key to the design. How long did construction take? Skyscrapers were built surprisingly fast. Some 20 to 30-story buildings were completed in just 1 to 2 years. This was possible because steel parts were prefabricated. Teams worked in parallel. Planning was strict. Speed came from organization, not machines. The workers. Construction crews included steel workers, riveters, carpenters, engineers, surveyors. Many workers were immigrants trained through experience, not schools. Their skill and coordination made these projects possible. No computers, only calculations. Engineers used slide rules, tables, and handwritten calculations. Every load, beam, and joint was calculated by hand. Mistakes were expensive, so precision mattered. Why these buildings still stand. Early skyscrapers were overbuilt. Engineers used large safety margins. Materials were thick and strong. Modern buildings are optimized for cost. Old ones were optimized for durability. That's why many are still in use today. What really built the first skyscrapers? not machines, but steel, steam power, organization, skilled labor, and careful planning. Technology existed, just in a different form. Final thought. When people ask, how did they build skyscrapers in 1900? The answer is simple. They used what they had, and they used it well. No computers, no cranes, no modern tools. Just engineering, teamwork, and a new way of thinking about buildings. And that was enough to change the world.